As I've mentioned before, you can use any collection that implements IEnumerable or its generic version as a data source for a LINQ query. You should note that our example uses multiple overloaded versions of the display results procedure to display output. I really don't want to dig into display results, it's just UI code, but you will see it used throughout these examples as a way to display the results of executing a query. Well, let's review by starting with a procedure much like ones you've seen already and see how you can use LINQ to objects. Our first example, G here, should look real familiar to you. It's just a simple query which takes in an array of numbers, and from that array of numbers will order by number and select the numbers. So what we'll get is the input array sorted numerically. It's not real exciting. If I run that full speed, we get the input array sorted numerically. That one wasn't very interesting. Let's go to the next one now, which introduces a new concept. In this example, we have the same input array. I'd like to see in the output only the numbers where the number isn't even. That is, where number modulus 2 does not equal 0. We'll get the odd numbers. Here, we'll order by that number descending just to add a new wrinkle, and we'll select the number. And of course, this query does exactly what you'd expect. It says, okay, for each number, let's calculate is the number modulus 2 not equal to 0. If it is, we'll include it in the output of the array. We'll then order by the output descending and select each number in turn. And we can do that. And you'll see we get only the odd numbers in descending order. Let's take it a little farther. We have number query the old way, that's I. Let's look at this one. This one shows the code you would have had to write if you didn't use LINQ. That is, we'd have to first create our input, just like we've done with LINQ. We'll create our output, which will be a list of integers. I'll call it odd numbers. We'll have to loop through the input manually, and for each item in the input, if the number mod 2 does not equal 0, then add that to our output collection. And we'll do that for each number in the input. When we're done, of course, we end up with the same collection of numbers we would have using LINQ, and we'll just call display results, displaying those odd numbers. So I have to think that letting LINQ do the looping for us here is better than having to declare the output array, or list in this case, loop through all the input manually, apply the where clause to each value, and if the where clause is true, add the number ourselves to the output collection. They're doing all of that work for you in this definition of the odd numbers query here. Now remember, this code executes as you loop through it. This code doesn't execute until you call the display results method. That's really the only difference between these two different techniques for getting the same result. Now you might wonder, how does the language compiler turn these LINQ keywords into a query? Clearly, somewhere along the way, these things need to be turned into methods of some class or something. I mean, that's how C# works. Those keywords do correspond to methods of a class. It's the system.LINQ.enumerable class that provides these methods. What does that code look like? Well, let's take this compiled program and look at it in ILDASM. Let me get out of here. ILDASM, you should know, is a utility provided by the .NET Framework that allows you to examine the compiled output of a program. So I'll take the Visual Studio command prompt, which I've put on the Start menu. If you haven't done that, you'll find it here under Visual Studio Tools, and there's the Visual Studio 2008 command prompt. I just dragged it onto the Start menu, so I can start it from here. Let me go to where this application lives. It's here. I need to go to the LINQ demo folder. I need to go to the LINQ demo folder. I'm pressing Tab, which fills in automatically the file name for me. Then I need to go to the bin folder, the debug folder, And there I am. I'll type ILDASM, and it's linkdemo.exe. Press Enter, and it brings up the ILDASM program. I'll go dig into it to find the code we're working with down here. So let's try, say, number query 1. If I look at number query 1, I find the code we're working with, and if I start scrolling over here far enough, I should be able to find code that calls methods of the system.link.enumerable class. There's an order by descending method. There's a where method. And if I go a little lower, I should find a select method. It's there somewhere to get the results we want. In any case, you can see that the IL converts my LINQ query into method calls on the system.link.enumerable class. In other words, that LINQ syntax is just syntactic sugar on top of calls to the enumerable class's methods. LINQ just makes it easier for you than having to call those methods directly. So instead of having to call enumerable.where or enumerable.orderBy or enumerable.orderByDescending, you just write a LINQ query, and the compiler converts that into the corresponding IL that's needed. So the compiler then converts keywords into methods. But IEnumerable is an old interface. And remember, we're working with things that implement IEnumerable. It's an old interface. It doesn't have a where method, a select method, a order by method, and so on. So where do those methods come from? They couldn't modify IEnumerable because then old code wouldn't work with it. They had to rely on a new ability to extend existing interfaces and classes without changing their definitions. These are available because of a new technique called extension methods. Extension methods exist in one class, and in our case, a new class, but allow code to extend a different class. So we'll be extending the IEnumerable interface by adding methods from the system.link.enumerable class. So system.link.enumerable provides methods which actually act as extensions on the IEnumerable interface, which has existed for a while. Extension methods add new methods to existing classes without changing their definitions. It's not just for LINQ. You can use this in any code, but it's crucial for LINQ to work. It's the basis for how LINQ works. In our example, we'll create our own extension method, but we'll be using extension methods every time we use LINQ queries. In order for an extension method to exist, it must be declared as public. It has to accept a parameter, the type of which defines the class that you're extending. So in our example, since we're extending the IEnumerable class, our extension method must have at least one parameter. The first parameter must be of that type. That tells the compiler what it's extending. It has to exist within a static class. You have to use the static keyword on the class definition. It must be a static method. You have to use the static keyword on the method itself. And you have to use the this keyword in that first parameter. The this keyword indicates that this is an extension method that extends the class that follows the this keyword. Let's try an example where we'll define our own extension method to make it simpler to create a LINQ query. If you'll remember from our earlier example, we had a where clause which asked for only values where number modulus 2 does not equal 0. That is, give us odd numbers only. If you did that often, you'd get tired of typing that expression, and you can imagine quickly a more complex calculation you'd like to make, and you don't want to include that every time. Now, of course, you could write a method and call that method passing in the number like we did with the double-it method, but we can also extend the integer class. We don't have to inherit from it to extend it, we just extend it. And I've done that here in the extensions class. Extensions is defined as a static class which has a public static procedure in it which returns a Boolean. Its name is isOdd, and its first, and in this example, only parameter has the this keyword applied to it. That indicates that this procedure extends the int class, the int32 class. So here we're returning value modulus 2 does not equal 0, true or false. Then back in our original code, instead of using number mod 2 equals 0, we can use the number.isOdd method. And you'll see I see that in the IntelliSense. It's got this little arrow there to indicate it's an extension method, and the extension keyword shows up here as well to indicate that it's not really part of the integer class, to indicate that it's not really part of the int32 class. Instead, it's an extension method added by some code. There we go. And we can easily add more extensions. I can just take this, copy to the clipboard, come down here, change this to say is even. Better type that right. Is even. And here, return not is odd, passing in value. And now we have an is even method as well. I'll save it and compile it. Go back to our code. And here, check the IntelliSense. And you'll see we have both is even and is odd as extension methods, and is even definitely wasn't there before. There we go. So we could have created our own is odd or is even methods that didn't extend integer and pass in the number as a parameter, but this is certainly cleaner and easier than creating a procedure which accepts parameters. And this is exactly the way LINQ works. Each of these keywords corresponds to a method of the IEnumerable interface, because odd numbers is something that implements IEnumerable, and it extends IEnumerable by adding new methods that allow us to use LINQ with that query result. Now, although this isn't the time to discuss them, the system.linq.enumerable class provides a large number of methods that extend other classes. In this example, we'll look for one of the grouping methods that allows us to group data based on the data itself. Again, these aren't provided by the source of the data, but instead by system.linq.enumerable, which extends the IEnumerable or generic IEnumerable class. Let's look at an example which introduces the concept of grouping in the LINQ query. In our example, we're going to group our input values into even and odd groups. We'll use the isOdd extension method to do the work for us. The syntax is a little odd, and you'll get used to it over time, but you see we start the same way. From number in numbers, order by number ascending, so there'll be an ascending order. Each of the groups will be. We'll group number by number.isOdd, so we'll use the isOdd extension method to perform our grouping into a property called grouped numbers. And we'll order by groupnumbers.key. Key is the value we use to perform the grouping. Groupnumbers.key will be the value itself. We'll order by groupnumbers.key descending. Now the key property is the thing we use to perform the grouping. And in this case, that's the isOdd value. An isOdd value is either true or false. So we're ordering by that Boolean value in descending order. So we're ordered by that Boolean value in descending order, treating the true and false as numbers. Now for the output, we'll select a new type, which is an anonymous type. We'll get the isOdd value, either true or false, from the key of group numbers. Key is a built-in property of the result of grouping, which is the reason why you grouped something into a particular group. In this case, that's the Boolean value indicating whether the number is odd or not. We'll also get grouped numbers. That is a list of all the numbers. So we're going to display for each item whether it's even or odd and the numbers themselves. That's what we'll get into our grouping. And then for each group that we end up with, there'll be two groups, one for true, one for false. For each group, we'll display the results whether it's odd or not. That is the isOdd property of our result value. See it there, isOdd? That'll be the property we display as a string. And then the group numbers. That's a collection, a grouping. and we'll display those results. Let's try this. Choose option K, and you'll see we step into this. We're going to execute that group number by number.isOdd into grouped numbers statement to group the result into two groups, even numbers and odd numbers. I'll run this full speed from now on, and you'll see we display the results. The first one for isOdd is true, and the second one for isOdd is false. These are in descending order by group, and then within each group in ascending order. I know that's complicated, but it does show off this group keyword, which uses an extension method of the enumerable class to extend the IEnumerable interface to allow us to group, in this case, by two values, true or false, into those two groups. LINQ to SQL allows standard LINQ queries to work with data stored in relational databases, not just arrays of numbers. It extends ADO.NET and adds support for mapping tables and rows to classes and properties. To support LINQ to SQL, you have to add custom .NET attributes to a class that represents your data's schema. We'll map a class to a table in a SQL database and map properties within the class to columns within the data. And we'll do this all by adding attributes. We could represent relationships as well between the tables, but to do that, you're better off using the Object Relational Designer built into Visual Studio, which we're not going to cover in this section. It's out of the scope of this section, but it will be covered in a different section of the course. So we won't be using the Visual Studio Object Relational Mapper, although that is the simplest way to build these classes. I wanted to show you how to do it manually first, so you appreciate the tool later on. We're going to retrieve data from the Northwind Customers table. We'll retrieve the customer ID, company name, contact name, country, and region fields, and we'll indicate the primary key, we'll indicate which fields correspond to which properties, and we'll rename a column just to show that we can. We'll start by creating a class with properties that correspond to columns in the database. That's the Customer1 class. And then we'll use attributes from the system.data.link.mapping namespace to mark up the various things in the class, like the table, indicating that the class itself corresponds to a particular table. We'll use a column attribute to indicate that a property in the class corresponds to a column in the table. And there's lots of other attributes you could use. We'll just be using a few in this demonstration. And that will be the finished customer class. Now we'll need some mechanism to manage the connection between the class and the data. You can't simply fill some huge data structure with all the data because there might be hundreds of thousands of rows and you can't fill them all in the memory at once. You need some class that converts requests for data into SQL strings and that executes the request and virtualizes the request so you don't have to fill in all the rows at once. The system.data.link.data context class does this for you. It includes members that provide access to your data. It tracks changes to data for updates. And the OR Designer, Object Relational Designer, built into Visual Studio, creates these classes and a new class that inherits from data context, making it really easy for you to do the work with LINQ to SQL. Let's try an example that does this manually, however. We'll create the class, and we'll use the data context class to go retrieve data from SQL Server. Using LINQ to SQL, I'd like to be able to use syntax like this. From some customer in some table of customers, where customer.country equals USA, select customer. That is, give me a list of all the customers from my Northwind customers table that happen to be in the USA. Well, to do that, we're going to need to fill in the customer table. And the code to do that is here. We're going to call the getTable method of a data context specifying what kind of item should be in that table. And then we'll need a data context to make that happen. But before we can do that, we need to define the customer type. So let's go to our Solution Explorer and look at our first pass through this, which is our Customer1 class. The Customer1 class has just a class called Customer1, has a property named Customer ID, company name, contact name, country, and state. Well, there is no state field within the customer table in Northwind. I know that. So we'll need to have some way to rename it so it knows which column to look for its data in. We also have a toString method, so when we display each customer, we'll see a formatted value. In this case, that's contact name works at company name in state, comma, country. Well, that's our first pass, but that can't work with LINQ to SQL because there's no markup that indicates how to map the customer class to the customer table. There's no markup that indicates how to map the customer ID property here to the customer ID column in the customer's table. We need that. We get that by adding markup information. Here's the same class modified. I've added the using statement for system.data.link.mapping to save us some typing. Now notice I didn't mention this. We're using the shortcut method for defining properties. I have public string customer ID and then here get semicolon set semicolon. It allows me to implicitly create a backing variable and just get and set the value of that backing variable without having to type all that code. It's a C# only feature in this version, though Visual Basic I'm sure will get it at some point, that allows you to create very simple property declarations without typing very much code. You'll notice that we've marked up the customer class with this table attribute. The name property that I pass to that table attribute indicates which table in our data source should map to this class, the customers table. Now here I've got a column attribute on the customer ID property. The column attribute indicates that this maps to a column of the same name. The isPrimaryKey property indicates that this is the primary key of the table. For company name, contact name, and country, I have a column attribute which identifies that this maps to a column of the exact same name in the data source. And here, I have a column attribute with a property, name equals region, which indicates that this state property maps to the region column within the data source. That's how you can rename data in your own class. ToString method gets no attribution because it has nothing to do with LINQ to SQL. It's just there for my benefit. And at this point, you're probably wondering, do I have to do all this work every time? And the answer is no. The Object Relational Mapper in Visual Studio will create this class for you. I just wanted to show you how you could do it yourself if you didn't want to use that designer, and now at least you know what the designer's doing. If we go back to our code, here, let's run it and single step through it. Here you'll see that we start by creating an instance of the data context class. The data context wants to know where to get its data from, and we've specified a SQL string that's stored as a property in this project, which indicates we're using the Northwind database from the SQL Express instance of SQL Server on my machine. Given that data context, we can call its getTable method, telling it what type of data to work with. Here we've indicated the customer class, that's the class we just looked at over here, and we'll place that data structure into a variable named customer table. I've used the var keyword here only because by looking at this code it's pretty clear, although before I said I wouldn't write code like this, obviously I did. In this case, that the contents of customer table is a table of customer instances. If I step over that, we can even hover over this and see that it is a table which contains customers. Okay. And now we're going to define the query. Customers will be the results of saying from customer in customer table where customer.country equals USA, select customer. Clearly, customer table must implement IEnumerable or its generic version, so we can use LINQ over that collection of objects. Finally, we'll display the results. And you see we end up with a list of customers from the United States. You might be wondering, is there some way to debug this to determine what SQL I'm sending to SQL Server? That's important stuff to know. So there are two ways to get that information. We can get the information either by calling the toString method of the query itself that hands back the query string that gets sent to SQL Server, or we can use the log property of the data context object and stick a stream into that property. We're creating a string writer in this code. That's a stream into which we can write output. Then you can convert that stream into a string when you want to see its output here. So let's walk through this procedure as well. This is M. Here we go. There's our data context again, setting up the log by setting the log property of the data context to be our string writer, set up the query, and now we'll display customers.toString. We haven't executed the query yet. We still haven't executed the query. If we go look at that, you'll see we have select t0.customerID, t0.companyname, t0.contactname, and so on from customers as t0, so that's our table, where t0.country equals some parameter value. We don't know what the parameter is, but at least we see what the SQL string would be. Next, we're going to execute the query. And finally, we'll display the log output by converting that string writer into a string, and you'll see in our console window, there is the SQL string, there is the parameter whose value is USA, and some context information about our query. So the log output gives you more information than just the toString method of the query, because if you ask for the toString method of the query, you haven't really done anything yet. Either technique works. You can call the toString method here or retrieve the log property of that data context. Either technique gives you the information you need, which is the SQL string that got sent to SQL Server to retrieve the data. Anonymous types work well with LINQ to SQL because you might want to retrieve just a subset of columns or maybe perform a calculation as you retrieve the data from SQL Server. We have an example that uses an anonymous type with LINQ to SQL to show off how you might use these on-the-fly created types with your LINQ to SQL queries. In this example, we'll retrieve just the company name and state properties of a customer. Now, we're not performing a calculation here, although we could, but I wanted to show that if you do this, you'll just retrieve the properties you ask for. So in this example, I'll run at full speed here. N. In this example, we're going to set up the data context just like before. We'll retrieve just customers in the USA just like before. But this time, we're only going to select the company name and the state properties of that customer. Now down here, I'm going to display that customer's collection. Now you'll notice a couple things. First of all, this code won't call the toString method of the customer class because what I got back is not an instance of the customer class. Instead, it's an instance of a new class, which just has two properties in it, and that's all. Here you see we get the results, but not formatted neatly. This is using the toString method that's built into the class, not our override for it, and it displays just the values of the two properties in that class. Notice that all we see are company name and state, because that's all we retrieved when we created this query. The customer class has multiple columns. We just retrieved two of those columns in this query. You've worked with LINQ to objects and LINQ to SQL. We'll finish this section by looking at a simple example of LINQ to XML. What if you need to retrieve, create, or query XML content? The .NET Framework on its own provides rich support for this, but the steps can be complex. And if you need to do much querying or formatting, you'll end up using XSLT and XPath, and those are complex techniques that require a lot of study. What if you could accomplish these same tasks using a standard syntax? And you know the answer is, what about using LINQ to XML? LINQ to XML definitely makes this possible, and our examples that we'll see in this section create new XML content. We'll look at our course class and a create course list procedure that will do the work for us. Now, without linked XML, creating XML content required multiple steps. There was the XML document class, and it will create new elements for you. You have to set properties of that element and then append it as a child of a new parent. And we have an example that shows off doing things the old way. But it actually becomes much easier using LINQ to XML. The system.xml.link namespace adds a bunch of classes that make it easy to work with LINQ and XML. There's the XElement, XAttribute, XComment classes, and all of these inherit from XObject, which is an XML object that you'll use with LINQ. Each one of these provides overloaded constructors. You pass as much information as necessary to generate the XML for an element, an attribute, a comment, or whatever, and it's much more readable than using the XML document class and code that uses that class. We have a procedure which will create XML content using these classes. In order to create XML data, we'll use the from and select clauses. The from clause sets up a range variable which iterates over our data source, which is our collection of X elements, and the select clause specifies the shape of the resulting data. In other words, it lets you project the data into a new format. The select clause always does that. We haven't taken advantage of that feature very much, but it does allow you to do that in any query. We'll take advantage of these facts to use LINQ to generate XML content. That content will be newly created XML using a collection of classes, and we'll spit out new XML based on that collection. In order to demonstrate working with LINQ and XML, we'll need some data. And to keep it simple, I've generated the data here in a simple procedure called createCourseList. It returns an array of course objects, and we can see the course objects here. And course does nothing more than get and set the values of 3 fields and provides a constructor for a title, a year, and an author associated with the course. Back in our code, createCourseList just generates an array of 3 of those courses. Okay, well, let's start by looking at how you might generate some XML. Well, what XML do we want? The XML I want looks like this. I have a sample.xml file here which demonstrates what I want the output to look like. I would like a courses element, within there an element for each course that meets the criteria that Robert Greene is an author of the course. So although we generate 3 courses in the code, there are only 2 courses in this output. Well, how do we make this happen? Well, let's run this procedure demo with no linked XML and try this first. Demo no link to XML is O. Here we are. Let's go full screen. And now we're going to do this the old way. First, we'll create the course list. So we have an array of courses, and there they are. There's the first one, and so on. We'll create a new XML document. This is all using techniques from before LINQ. And you'll see it requires a lot of code. We first create the courses element and call it root. And then for each course, named item, in our collection of courses, if the item.author.contains, well, there's author, it does contain Robert Greene. If it does, then we'll create a new element named course by calling the document's createElement method. We'll set an attribute on that element of year to be the year the course was written. And then we'll append this as a child of the courses element. Now we'll create the children of this new course element. We'll create an element named title, set its text, and append it as a child of the course element. Do the same for author, append it as a child of the course element, and repeat that for each course in the collection of courses. When we're done, we'll append, we're not quite done yet. There we are doing the last one. When we're done, we'll append root as a child of the document, so it's now connected with the XML document, and we can display the results And you'll see that we did generate that same XML. It's not formatted correctly, but it is well-formed XML. You can see the courses element within their course element. Within the course element, we have an attribute for the year and an author and title element, then a second course element, and within it, a title and author element. So it is exactly the XML we wanted. It was just difficult to generate. Well, let's do the same thing. Well, let's look at the new way of generating XML content. This is option P here. And we won't use LINQ to XML here. Instead, we're just going to show off the new classes that are provided to make LINQ to XML possible. There's the XElement class and XAttribute. There are lots of other X classes, XComment, and so on. But all I need is XElement and XAttribute here. So we start by creating a new XElement object named XML. And in the constructor to that class, we pass in the name of the element, courses, and the content of the element, which is this stuff. Well, the content is a new XElement named course, and its content. Well, it's got an attribute named year, the value of 2005, an XElement named title with the title of the course, and an XElement named author with the author of the course. If we run that, you'll see without really writing much code at all, we've generated this very simple XML. Didn't require creating nodes and appending them as a child and setting properties. We did it all declaratively right in the code here. Not only is this easier, it's easier to read. You can see this code and understand what it's going to look like once it becomes XML. It's a great feature. But let's use LINQ and XML together now to generate all of the content. I'll press option Q, and here we are. And in this case, we'll do the same sort of thing, except we'll do it for all the courses. So we generate our course list, and now we're going to generate the outer courses element by creating a new XElement named courses, and this then supplies the content of that courses element. Okay, well, what is the content? From course in courses, here's our courses variable. So for each course in that collection, where course.author.contains Robert Greene, so we're using a where clause, then we have a select clause, a LINQ select clause. The select clause allows us to project the output in any format we want, so we can project out a new XElement named course for each course, which contains within it this content. And the content is a new attribute named year with the year in it, a new element named title with the title in it, and a new element named author with the author in it. And we repeat that for each course in the full list of courses because that's what the from clause says to do. So the from clause indicates where to get the data, the where clause indicates how to filter it, and the select clause indicates how to project the data into the resulting XElement object. If we run at full speed, we get the exact XML output we wanted. That is, a course's outer element, two course inner elements. In both cases, Robert Greene is an author. We get the year attribute and title and author child elements in each case. So here, we've used LINQ to XML to generate the contents of this courses element. We haven't done any querying yet. We've just generated new XML content using LINQ to XML. But you can certainly see how this is an important and useful feature for creating XML content.